All right, next we're going to talk in our discussion about regression about cats. Just kidding. It's been a while since October has popped up on stream. Me talking and recording videos puts them to sleep. I hope they don't put you to sleep. All right, let's talk about different features that we're going to look at when we look at scatter plots. And we're going to give these as kind of informal definitions. The book has much more formal definitions if you want them, but just gonna kind of give like pictures, these ideas, and we'll talk about these different aspects of scatter plots. So you might have a scatter plot that has linear form. Okay, the form can be linear, the form can be curved. Maybe there's no pattern on GeoGebra, which we'll look at later. GeoGebra has all sorts of different patterns that you can get: logarithmic, exponential, quadratic, polynomial, sinusoidal, all these different ones. But in general, we're going to mostly be looking at linear data. So maybe we have a scatter plot, and this data, the scatter plot, vaguely is progressing in a line. All right, this would be an example of weak correlation. But yeah, right, on average, the numbers are bigger on the right than they are on the left. Or we could look at curved form, right? And maybe our scatter plot, maybe our data points look like this or something, right? And then, if we wanted to find like a line, wouldn't predict this, right? But we could maybe predict this one with like a quadratic or a parabola or something. We're not going to talk about that in this class, but it could be a thing. No pattern is, maybe we're talking about two things that are not correlated at all. They have no connection. Maybe just we have data points all over the place. And there's just doesn't seem to be any relationship. So that's one aspect of scatter plots, the form. The direction, this is going to be, we'll say positive correlation or negative correlation, or neither. Again, positive correlation means that an increase in one variable leads to an increase in a second variable. So you can think of like positive slope. And that's a big thing that maybe I will write down. An increase in x leads to an increase in y. All right, positive slope means going up. And then likewise, negative, might look a little something like this, where an increase in x is a decrease in y. Decrease in y. And then maybe there's no correlation. Maybe there's no direction here. And there's kind of two situations. One is like, just like we looked at before, maybe there's no correlation at all. Or maybe the slope is 0. Again, no correlation or 0 slope. So even though the second one is a line, notice that changing x doesn't have anything to do with y. We change the x, go left and right, the y value doesn't change, there's no correlation. Okay, so we'd still say neither direction in either of these cases. Increase in x has nothing to do with an increase or a decrease in y. Strength has to do with how close things are to a line. So if we have really strong correlation, again, so direction, we can think of it as slope. Strength in general is how close the points are to a line. So an example of strong correlation might be something like this. Whereas weak correlation, you know, it's still positive maybe in this case. Right, this is positive correlation. But notice that the data points are much more spread out, even though they still kind of fit the same general line. All right. And then medium is just going to be somewhere in between. We'll talk about how to quantify this later on with a value called R. Okay, so moderate, you know, just try to get some graph that's kind of in between, not as spread out as the second, but more spread out than the first. And it doesn't have to do with the number of points. It's just how close they are together, so we could add more points to these other ones to make it look more like that last graph. It has to do with how spread out they are in general. All right. And again, we will quantify all of these more. Quantify, I mean, give numbers, right? Explain all of these with numbers instead of just vague descriptions. We're sticking with the vague conceptual stuff right now as an introduction. Outliers, we've talked about those before. You know, again, maybe we have pretty strongly correlated, strong positive correlation maybe. But then we have one data point way over here. Okay? It's an outlier. And in general, outliers are like 2 standard deviations outside of the regression line. The book, again, has much more strong definitions about that. When we did data points, we used those fences by multiplying, adding 1.5 times IQR to the third quartile and subtracting from the first quartile the same amount. That's how we did it for data points. Well, there's ways to do it with standard deviations for these. There's also something called influential points, which we won't really talk about in this video, but something to be aware of. Okay. And then the last thing that we're going to not really talk about so much here is groupings, which, yeah, I don't really want to get into right now. Okay. So we won't really talk about it, but in general, all right, let's say very briefly, right? In general, groupings is, you know, maybe our data points, like we have some data points for men and some data points for women or something. And so you can kind of look at, you know, maybe you have like 2 kind of different trends. If you like group your data differently. So it's more interesting if you like look at the individual groups here. All right. And so those are the various aspects of, scatterplots: form, direction, strength, outliers, and groupings, things to be aware of. All right, good luck.